Hey, everybody. Welcome to the second Avalanche Developer Community Call. You are joined today by myself, Gabriel Cardona, developer evangelist from Ava Labs, and three of the most amazing Blockstar engineers that we have from Ava Labs. First, we are joined by Patrick O'Grady. Patrick is our VP of Engineering. Next, we have Stephen Butoff. Stephen was the very first engineer hired at Ava Labs, and he's the creator of Avalanche Go and just an all-around amazing engineer. And then lastly, we have Aaron Buchwald, who is the creator of basically the C chain, what we call Core ETH, and then Subnet EVM, and did a bunch of work on precompiles and just another absolutely amazing engineer in the Avalanche ecosystem. So as I mentioned, this is the second developer community call. Our intention is to do these every 2 weeks. So I've had a couple of people ask me online, do we have set dates so that I don't have to just look on my Twitter feed. I think we're shooting for around April 5th, but that's not entirely hard-coded yet. So check back again now on social media, but hopefully in the future we'll have these dates set in stone so that people can kind of plan in advance. Also, we have a form that we've been sharing over social media to gather questions. So we're hoping that in the future, if you have questions, you'll know where this form lives and you can submit them even anytime over the course of that 2 weeks. And we'll have them all gathered and ready. We also have the ability for you to appear with us live to ask the questions here. So if there's something you want to connect with our engineers about, make sure to keep your eyes out for that next time. So anyway, I'm very, very stoked to be joined by these three gentlemen. Thank you so much for your time. I'm going to pass the mic over to Patrick now for the first round of questions. Go for it, Patrick.
Yeah, sure. Thanks for the introduction, Gabriel. Happy to see everybody again. Before we get started, I want to just call out we have basically the Avalabs engineering protocol engineering team is working on a recap of the bug that caused degradation on the network for a few hours yesterday. So stay tuned for that. We're targeting a release of that in the next 48 hours or so. So thank you for your patience while we put that together. So we're not going to talk much about that today, and we'll get into that in a few days once that recap is out the door. And so today we're going to talk about some really fun stuff that's coming to the Avalanche network. So as you saw a few days ago, we released Avalanche Go version 1.9.12, which is in large part just preparing for this upgrade that's coming in Cortina. And so instead of spending too much specific time on 1.9.12, which is really just preparation for Cortina, we thought it'd be a lot of fun and really just more interesting to go right into what is coming in Cortina and what that is. And so with that, I'm going to hand it off to Stephen to introduce Cortina. And Cortina, the full release and blog post and everything like that will drop in the next few hours. So this is just kind of a sneak peek, and then we'll have a detailed blog post you can refer to very shortly. So yeah, Stephen.
Yeah, so super excited to talk about this. We've been working on Cortina for actually probably almost immediately since mainnet launched. So immediately after mainnet launched, my first kind of endeavor was to start working on epoching on the X chain and on DAG-based consensus in general. And so we spent a lot of time digging into how best to do that. And so now we're kind of finally getting to kind of the culmination of all of that work. So what Cortina's primary focus is migrating the X-chain consensus to use Snowman++. So there's a couple other kind of UX improvements, both on the P chain and the C chain that we're going to dive into, but I'm going to probably focus on kind of what the Cortina means for the X chain. So since the beginning of the network, the X chain has been running the Avalanche consensus protocol, which is this DAG-based consensus. And there are some definite challenges and limitations when you start running a partially ordered protocol. So one of the main restrictions is that it's really hard to actually succinctly summarize the state. So what you need to do is you need to have what we originally called was epochs, or some essentially like points of common decision on what the full state of the network is. So what we ended up doing is we ended up digging into the Avalanche consensus code to start adding support for basically having a summary vertex. So that summary vertex could basically have a choke point or a linearization point to then like re-kick off further decisions. Once we started digging into Warp as well, though, Warp ended up tying in a lot with Snowman++. So the way that Snowman++ actually works is it has references to the P chain to specify validator sets, both for the proposal mechanism, but also for the actual Warp message authentication. And so in order for a chain to support Warp messaging, it also has to be using this Snowman++-esque mechanism. And then on top of that, we have kind of more complex features that we wanted to add into the X chain that might not be super conducive to a partial ordering. So a great example of that is more interesting, say, contracts or things like that that touch on global state rather than kind of a user-owned state module. So all of those things, we ended up basically thinking for a really long time on, okay, like what's the best way to do this on a DAG? And essentially we came to the realization that for us, it made the most sense to just unify and reuse Snowman++. That is true both for us and for external parties. So external parties such as either explorers or exchanges generally require some notion of time and indexing to like have some consistent globally agreed upon state of network operations. And so that's generally not useful or possible in a partially ordered protocol. And so essentially the plan is for when Cortina activates, we are going to perform one essentially epoch vertex or a stop vertex or a linearization vertex that will then kick off the Snowman++ block production mechanism going forward on the X chain. So that should really accelerate the development and the usability of the X chain. And so this is something that I'm really excited about, and it's probably one of the cooler network transitions that I think I've seen. Yeah, I'm really excited about it. I would love to dive into the technical details, but I think right now we're just kind of saying a bit of a summary about kind of what's going on. So that's kind of the main thing that's happening on the X chain for Cortina is we're switching from the Avalanche DAG-based protocol to the Snowman linear-based protocol on the X chain and kind of fully unifying all of our consensus protocols around Snowman++. In addition to that, we're also...
Let me chime in there real quick before
go for it.
keep going. Yeah, so I mean, I wish we had a visual aid to kind of show like something cool that's going. Actually, I think we probably have some.
I have a whiteboard out.
No, I think there's. I'm just gonna put it in the background because it's. I just want to put a picture so it's less, so it's a little bit more visually appealing here. Give me a second. There we go. Can you guys see that all right? Cool. So on the docs page, there's a link that we have a bunch of awesome information about, DAGs and blockchains and everything like that. So thanks, Stephen, for, covering a lot of what we're doing there. And so, yeah, the X chain will be migrating to Snowman++. And so what that means for most people, from a transaction perspective is fortunately nothing, right? The transaction format is identical. There's no change there. The APIs to like broadcast a transaction and check a transaction are also identical, so no problem there either. So if you have a wallet or you're doing something basic or standard on the X chain, like you will see no change whatsoever in the API. It'll all of a sudden just be a chain instead of a DAG, which a chain is just a special case of a DAG anyways, but not to get into that. But the change that people will have to take advantage or like really update to is if you run an Explorer or something that indexes X chain activity, you'll basically, instead of reading vertices off the index API, you will instead read blocks off the index API, which if you already parse the P chain, look almost identical. And so what we'll do is instead of when you like basically get a vertex off this thing, instead of actually like iterating or basically going through the vertex transactions, you'll just go through the blocks transactions, which are identically formatted. So for many people that have, the code is actually out now, V1912, which includes all the changes to the parsing and everything. You can take a look at and start taking a look at this, but we'll share an integration guide that will help people actually update here. And so we kind of dog fed this change to our internal teams because now we have this data platform team that runs these different explorers to get their feedback on what would make it palatable for people to migrate to on a relatively quick time frame. And we landed somewhere I think that we're pretty happy with in terms of what the actual integration overhead is. But to go back into this a bit, people have always been like, you focus so much on the C chain, you focus so much on the P chain, you focus on so much on the subnets, but what about the X chain? Like, it's just kind of there. And the answer to that is no, it's not just kind of there. The issue is that with the DAG, at least in the way that it's constructed on the X chain, it's actually really difficult to upgrade and it's difficult to iterate quickly on it. And so, it's not impossible to create like a totally ordered, it's very complicated to create a totally ordered, process on top of a DAG. But to do that on the X chain would have required basically just a rewrite of the X chain. And so it was a question of, do you rewrite the X chain and totally change how the DAG works to achieve that? Or do we just use something that everything else is using, especially given, Avalanche warp messaging compatibility? And to us, it was a question of not only warp messaging, but like how applicable is this to subnets, right? Because the primary network is great for, getting started, managing some flows and that's secured by everybody. But, on Avalanche, the scaling comes from subnets. And so if we're spending all this time working on this consensus algorithm that has no applicability to subnets, it raises questions about like the engineering efficiency and leverage of the R&D work of Avalabs. And so we concluded that, at some point, we felt like we could get what we needed from Snowman++, and then by doing so, stop having to research so many different avenues and really focus on the optimization of what people are already using. And so we hope that this will not only improve the speed at which we can continue pushing updates, but also add more interesting functionality to the X chain, which has mostly been simple UTXO-based transfers. And as Stephen alluded to, the individual vertices don't have a canonical state because, you can produce a vertex that references other stuff at any time, right? So like if two people produce a vertex kind of at the same time at the same height, well, like there's no clear state there, right? Like, so you have to, you can't do things that manipulate shared objects. Instead, you have to store data on UTXOs, which you can do. People do that. But I think most people are used to smart contracting and like complex interaction model that involves a shared object and state rather than actually like manipulating smart contract UTXOs, which you then have to like, make malleable so that you can like sequence them at some sort of high throughput. So, long story short, this should make the X chain much more useful, make it easier to integrate for different exchanges. And then I think the last thing I really wanted to touch on here was that the X chain right now is where all assets are defined that will be used on Elastic subnets. Now we're working on changes that will enable you to create those assets on the C chain. So like if you have an ERC20, you can make that the stakeable asset of an Elastic subnet. But right now it's just the X chain. And there's naturally a question of like, well, if that's what's happened on the X chain, well, like, first of all, it should have two things probably. One, like it should be super easy for any exchange to integrate because that's where a bunch of tokens will live that'll be critical to the growth of subnets. Well, with the DAG, it's not. Like exchanges find it very difficult because they can't actually reconcile balances at different heights because there is no canonical state at different points. Secondly, it should have some functionality that maybe allows you to like trade tokens or something like that because that's where all the tokens would be. Well, you can't do that very easily on a DAG as well because of the stuff we talked about. So you'd have to like have some protocol where people kind of agree to a trade outside of the thing itself. Like you can't provide liquidity. Instead, you just like match at the time and then both sign like a shared UTXO object, which you could do again, but like kind of complicated. Like you have to have everyone online then. So like if there's a trade that happens, like both parties have to be aware and available to sign the transaction. You can't just like have resting trades that occur. So it just gets complicated. So this is really about unifying consensus so we can increase our R&D focus on a particular topic It's about, paving the way for warp messaging support on the X chain. It's about adding more complex functionality, and really, all in all, just making the primary network more efficient. So we'll see how that goes. But we're pretty excited, and the technical post coming out will go into this in more detail. And then so big change, crazy. It's been happening, or we've been working on it for so long now, and so it's great to see it finally come close to actually getting out the door. So yeah, but I think the next thing you wanted to talk about was the batched delegated rewards. So let's turn it over to you, Steve.
Yeah. So another kind of common issue people run into if they're running a larger validator is that whenever you get a delegator delegates to you, whenever their delegation terminates, it produces two UTXOs, one for the validators portion of the reward, and one for the delegators portion of the reward. So if you're a validator, it is not uncommon to get thousands of delegations. And so what that means is that for a single validation period, you might have a huge amount of essentially dust UTXOs that are produced that you would have to kind of coalesce. And it's actually really annoying because sometimes you get so many that it can't even fit in a single block. So you actually have to split it up, and the wallets are not super great at handling these cases. And so the key kind of point here is that these are dust UTXOs for the most part. And so validators probably don't want to actually have those. They want essentially a balance where they have all of their rewards. And so the way that the delegator rewards are going to be allocated post Cortina, so specifically for validators that start validating post Cortina, so people are grandfathered in if this is a change that changes how people think that they would have wanted to enter the validator set or whatever. But for any new validators, delegation rewards will basically just be attributed to the validator and all rewarded in a single UTXO at the termination of their validation period. So now, rather than having thousands of UTXOs strewn out, you have a single UTXO that accrues all of the delegation rewards on the P chain for your validator period. This is really one of just kind of the first steps of some more staking improvements that we're trying to make as a whole. But this is a really common barrier that people have run into and a common issue. And so we wanted to kind of get that in as soon as possible to kind of unblock people. So that's the main kind of UX improvement that we're trying to get in for the P chain network upgrade. I don't know if Aaron wants to talk about the C chain improvements, or if Patrick, you have anything.
I wanted to add one more thing here. So people that have a lot of UTXOs may have noticed that actually there's a huge constraint in hardware wallets to sign transactions if you have a lot of UTXOs. And so what you end up having to default to then, if you have a lot of UTXOs, is to just sign hashes. Sign a hash of the transaction instead of actually being able to parse the whole transaction on a ledger, for example. So that's very suboptimal. So this also directly improves the security UX, because you don't have to end up signing a transaction with thousands of UTXOs on a hardware wallet, which is strictly not recommended by Ledger. In fact, if you go on Ledger's website, you'll see that they say, is it good to even send mining rewards to a Ledger address for Bitcoin? And they'll be like, no, don't, because the amount of signing you have to do with UTXOs is not what Ledger is optimized for, the hardware wallet. So this should also, get rid of that case, which a number of people have also reached out to ask about why that happens. And it's because of the physical memory limit on a hardware wallet actually makes it difficult or impossible to actually sign a transaction in full when you have so many UTXOs. But yeah, I mean, this is a classic case of, when the network launched, there weren't that many delegators, so people weren't getting that many delegation rewards, right? But as the launch of liquid staking and a bunch of other initiatives happened over the last few months, this is just a engineering solution to fix a scaling, of the P chain, which is now people get a bunch of really tiny rewards that are useless to them. I don't think there's anyone that I've ever talked to that said, wow, I wish I had more small UTXOs. They want it less and they want them together, which should also make doing financial analysis on the token rewards you get much easier too, instead of having to go to an Explorer and potentially pull thousands of things, especially if you've been validating for like a single year period. You'll now just pull one. So it should make everything much, much simpler. But I don't know if Stephen mentioned this, but just to reiterate, we are not going to make this change to people that are currently validating, because like the reward, basically they may be expecting certain semantics when they're validating. And so what will instead happen is that it will, after the Cortina activation time, it will apply to new validators. So anyone that is currently validating will have the rules that they expected and the semantics they expected on the chain. But then if you decide to validate after the Cortina activation, your delegation rewards will be badged, and there's not an opt-out option. It is the only way. So, yeah. But yeah, we can continue with the next thing.
Yeah, I think the next thing is the C chain changes. So for this, currently on the C chain, there's a static gas limit of 8 million gas per block. And the reason this is lower than some other chains is that Avalanche actually produces blocks differently than other chains. It produces blocks in a quiescent way and at a different cadence. So roughly we target producing a block roughly every 2 seconds. And that means that even though we have a block gas limit of 8 million over the course of 10 seconds, we will have a total gas limit of approximately 40 million. And so we would like to try and increase this, basically because we've gotten a lot of feedback from the community that even though there is this overall gas limit over the course of 10 seconds, the block gas limit actually serves as a bottleneck to any individual transaction that might be extremely large. So for certain transactions that are bundling a large number of operations together or deploying a series of contracts, the 8 million gas limit can actually be taken up by a single transaction. And this has actually been blocking a number of different large projects that we're really, really excited about that I can't name here from deploying on Avalanche. So this change is actually going to unblock a number of different projects, and we're going to be increasing that block gas limit from 8 million to 16 million. Yeah, here's the article.
Yeah, so this is the original blog post, and I'll turn it right back to you in a second. So Apricot Phase 3 is what actually introduced these dynamic fees and like goes into explaining how some of the differences are, where it's like a time-based rolling window fee calculation, which shout out to Aaron for coming up with the algorithm that does that pretty nicely. I came up with one myself to begin with, and it was terrible, and Aaron found a much better one. So I don't think anyone knows about that credit, so credit to Aaron for that. But yeah, sorry, Aaron, go ahead. So if you want to learn more about how exactly that changes and how exactly it works, I should say, you should check out the Apricot Phase 3 post.
Sure. Yeah. Actually, I can go into that a little bit too. Basically, in this, the real shout out goes to EIP 1559 and the Ethereum crew, and I think Tim Roughgarden as well from NYU or Columbia that did all of the research there. We really borrowed pretty much everything from this. The one adaptation that I contributed and that we made to it was in order to adjust this to the fact that we have a different block production schedule than exists in some other networks. So we wanted to modify this mechanism from adjusting every single block to adjusting based off of some interval of blocks produced within some amount of time, so that we could make follow essentially the same algorithm, the same fee schedule, while accounting for the fact that we may produce 5 blocks in 10 seconds as opposed to a target of 1 block over the course of 10 seconds. So the change that we did was actually to switch from, or I can start by explaining what EIP 1559 does, is it'll just look at the parent block, and then based off of how much gas was consumed in the parent and how much gas you're going to consume, we'll actually just do a single state transition based off of how much gas was consumed in the parent in order to calculate what change should be made to the base fee from the parent to the new block. And so that means that there's just a very, very simple transition based off of a single block that is very straightforward to understand. For us, we wanted to account for the amount of gas that was consumed over some roll-up window or a time interval over the past 10 seconds in order to bridge that gap between a transition from a single block to take into account how much gas was consumed over the course of 10 seconds instead. And so what we actually do is we calculate how much gas was consumed in the past, in each block that was within the past 10 seconds, and then encode the amount of gas consumed into the extra data of the block according to a specific formula. So you can actually encode this uint64 that says this is how much gas was consumed at 10 seconds before this block. And then you can just and do that for each of the past 10 seconds or an arbitrary window. And then you can basically just look at the previous block and roll that window backwards based off of the difference between the parent's block timestamp and your own timestamp in order to calculate exactly where that window should be rolled back to. And that way you can actually use the exact amount of gas that was consumed in each block over the past 10 seconds. So we can essentially adapt EIP 1559 to fit into our own block production mechanics. So the one additional change that we're making beyond the block gas limit is beyond adjusting the block gas limit from 8 million to 60 million, we're also going to be adjusting the minimum base fee. So when we originally launched the dynamic fees in Apricot Phase 3, and you can see the roll-up window here. When we originally launched this, we wanted to do this in a very conservative way within some reasonable bounds of what a reasonable gas price should be, so that if anything went wrong, we would still have a very reasonable bound that it will stay within, between 75 gwei and 225 gwei as the gas cost. And so we've slowly been adjusting that down in order to allow this algorithm to basically do its work and determine what is a fair price for the network. And so now we're going to be reducing the minimum gas price from 25 gwei all the way down to 1 gwei as well. So this means that when the Avalanche network is operating below capacity, the gas prices will be significantly reduced from what they are now, which will be really, really nice for users. So in summation, the little TLDR is gas is the thing everyone wants to hear is gas is going to be a lot cheaper.
Cool. Give me 1 second here. Next thing ready. Cool. All right. So with the Cortina stuff, like I said, there'll be an announcement later today with everything in detail for you to check out. Naturally, the X-chain, linearization and migration stuff is a massive change, probably the largest change that's ever occurred on the network. Stopping a DEG is pretty difficult to do safely, and so a lot of work has gone into this based on a lot of conversations we've had with people all over the community on like what sort of things that they would like to see improved on Avalanche and where things are going. And so, if you have any feedback on this and like things you'd like to see, please reach out at that time once all the details are shared, so you can read it in full and understand the feedback that other people in the community have provided about everything. And so I think from there it should be we'll also talk about when basically the code that will run Cortina is actually out already. But the activation timestamps that will be in that code are not actually included yet. But the blog post will contain basically dates to that the upgrade will be applied to Fuji, or the activation timestamps for Fuji. So so that's everything Cortina. So we're 30 minutes down or so already. The next thing we were going to talk about is the Warp messaging addition to the Hyper SDK. So I'm going to pull that up now. So give me a second. So I should have had my usual strata of tabs ready to go here. So let me present my screen again.
I think as you're doing that, one thing as well that we're going to be doing kind of in the migration post Cortina is, rather than doing our dev internally in an internal Avalanche Go fork, we're going to be switching to primarily doing all of our development off of the Avalanche Go repo itself. So as part of like doing these calls and trying to be a lot more transparent about the development process, we're not only going to do these calls, but we're also going to be transitioning much more to be using the Avalanche Go repo publicly, kind of as a much more standard open source software. So that's another thing that I'm really excited about, kind of as this migration passes, that we're also doing. It's not really code related per se, but it's something that I'm hoping will kind of like drive further engagement within the community for developing these kinds of network upgrades. So yeah.
Yes, I mean we've been kind of piloting our like better management of open source collaboration with the Hyper SDK and the Subnet EVM. And we've been pretty happy with the way that has been going. And so yeah, I mean, I think that the big thing here is like as Avalanche Go becomes more sophisticated and like continues to add more features, like it's really important that people that are building on the network, have a clear voice in like the features and changes and everything that is going on in Avalanche Go. And I think doing it kind of like the initial project scoping and development more in the open should allow people to better engage with that process. And the community calls we're doing obviously, start that effort and try to really get people up to speed on the things that we've been thinking about and working on in private a bit to let people, hopefully catch up to speed and start to contribute. So yeah, with that, we'll turn it over to the Warp kind of functionality that's been added to the Hyper SDK. So back up, right? So Avalanche Warp messaging, which I think I've talked about a number of times here, but just to summarize, is long story short, the ability for subnets to send messages and transactions or assets to each other. And so for a long time, people are like, subnets are interesting. I get it. You can like have your own node and scale it up and, everything like that. But like, I'm going to have a ton of different subnets. Like, how do they actually communicate, right? Like if I'm just on an island, basically just having my own chain, like there's no benefit in being part of the larger Avalanche network, right? Like if I did that, why not just kind of build my own? And the reason, what makes kind of partnership, like basically integration with the rest of the Avalanche network useful is warp messaging, which is the ability to rely on the staking information stored on the primary network to quickly and efficiently verify messages that you get from any other subnet. And so what that means for many people is, hey, I'm subnet A and I want to go to subnet B and move some tokens over there. Well, if I did that in a traditional setting, I'd need to have some sort of bridge that kind of spans that gap for me that I can move things across. And I think there's a general feeling in the space that we want to try and get away from bridges as much as possible because they introduce a lot of risk into that flow. Well, what you can do with Warp instead is that the recipient subnet of your transaction or your message can say, hey, this message was signed by 80% of stake of subnet A. Well, now I'll accept it because I know that it's secured actually by the entire exporting subnet, not just someone running a server or like a series of servers that run this bridge connection. And so additionally, it's not really the relayer itself that can move a message across, can be anybody. It doesn't have to be some like privileged relay or anything like that. And so lastly, what that also enables, and why I'm talking about this part is because it's a big part of kind of the Hyper SDK component, is that there's no additional overhead per connection between subnets in Warp. So there's no like connection or channel state that is maintained, which means that it's just as easy or cheap to go from like subnet A to subnet B as it is to go from subnet A to subnet C, right? So there isn't like these kind of highways that form where like you're trying to amortize the cost of keeping connections up to date. Instead, you can just kind of go point to point at any time. And so this allows for like a much, I think, a pretty cool UX where you can just kind of hop around as needed for what you're doing. So, but, we talk about how great Avalanche Warp messaging is and how much we like it. And then people naturally follow that up with, well, how do I use it? Or how do I try it? And so when Avalanche Warp messaging was originally shipped, it was included in a demo virtual machine that Steven put together called the XSVM, which is public. You can check it out just as a proof of concept to show that it was possible. And so we did the first warp transfer on mainnet using that virtual machine. And it was a lot of fun. Things moved around. It was great to see that it worked as expected. But it was never really meant to be like a long running thing or anything like that. It just was to kind of make sure everything worked and help us understand what abstractions we needed to actually to pull it off. And so we have been working on an integration of warp messaging to the subnet EVM, but getting that right is very complicated because we really want the semantics to fit well within the EVM, right? So if you just like had some like bolted on thing, it's going to be really difficult for contracts to interact with it and people to actually use it in an EVM native way. And so a lot of time has gone into actually designing those abstractions to make sure they make sense in that context. But because that's taking a while because it's so complicated to get quite right, I thought it'd be a fun idea to just implement it into the Hyper SDK, because the adding warp messaging support is a core feature of Avalanche, and I felt that any like virtual machine or SDK focused on Avalanche, table stakes to have warp messaging in. And it makes a lot of sense for the Hyper SDK because there's a lot of interesting semantic concerns you need to have when doing it that are very very generic. So that's perfect for an SDK because it means that everyone needs this complex functionality, but they themselves don't need to really tune it or make it different in any way to support most use cases. And so for Hyper SDK, that's perfect because that means that like I can take care of all this like low level stuff behind the scenes of like collecting signatures, producing multi-signatures, like managing warp message execution, things like that for you. And then all you have to do is specify like what actually goes in a warp message that's interesting to your virtual machine. And so I didn't know how long this would take or like how many lines of code it would end up being to actually implement, but it ended up being a pretty large PR. And so had a lot of fun. You can see I tried to, kind of clarify everything that I thought about as I was doing it to, make it clear, like kind of what the development process for something like this was. So the way that it works on the Hyper SDK, which I think is a decent model for the average integration into Warp, is that what it'll do is basically every block contains or basically every transaction contains now a warp message field where you can either export or import a warp message. And then the actual core Hyper SDK will take care of verifying those messages and then providing them into like your Hyper VM code that you can then use however you want to. And so then it also comes with a client that will then aggregate individual validator signatures and then produce a multi-signature on top of those individual signatures that you can use to import somewhere else. So there's a bunch of like low level, like BLS related stuff that's taken care of for you, as well as like the actual, RPC calls that are needed for this. And so not only did I add a bunch of end-to-end tests that show exactly how this is done, but then I also integrated it into the token VM, which is kind of becoming our reference Hyper SDK virtual machine here, that produces a demo. And so I shared that demo a few days ago. So if you want to check it out, you can see so. But you can hop around all these token VMs that understand each other's message format pretty easily. And so after the Cortina release is out and posted, I'll be spinning up the first DevNet that you'll be able to try out to see what it's like to use warp messaging between different token VMs. So we're pretty excited to see how that goes. And I think, to me, warp messaging is what people use for the first time on Avalanche, and they're like, "Wow, this is I get it now." And so I think the cooler that we can show, like the sooner and cooler stuff we can show that uses warp messaging and different things that rely on Avalanche specific things that make building virtual machines on Avalanche really awesome, the easier it is for people to kind of wrap their head around some of the network design that makes this possible. So yeah, should be pretty cool. And like I said, it's all public. So if you want to check it out, just go to the Hyper SDK repo and you can read about it, learn about it. And if you have any questions, as always, paste them into the discussion section. So yeah, Gabriel, I think we can probably go into some questions now.
Wonderful. Thank you very much, gentlemen. As always, incredibly informative. So there are several questions which we've got from the audience, which are related to X-Chain. So at this point, we're saying that, as Patrick mentioned, there's a blog post coming. So look for that blog post, and then if there are additional questions after that point, reach out to us on social media and/or check in with us on the next Avalanche Developer Community Call. So we have a few different questions, which we will now go into. A couple which were left over from our last session. So if you're watching this from last time, shout out to you. And then a few that were submitted today. As I mentioned, we're taking questions via this Google Doc, which we've all shared on social media, or via the input field, the comment field on the live stream on YouTube or StreamYard. So if you're tuned in to either of those channels, drop questions into the comment field now. If we don't get to them, we're still gathering them and we'll get to them next time. So first we have a question from Zaya related to HyperSDK. Could someone easily implement native account abstraction using HyperSDK, something like StarkNet or zk-sync?
Yeah, this was a good question. This was actually an explicit design goal of the HyperSDK. So if you can share my screen one more time, you can read about how exactly this works on the HyperSDK repo. But instead of like having an embedded set authentication mechanism in the transaction, which was actually, let me share a different screen here. You can keep my page up. So instead of having an authentication like standard scheme imposed in the transaction, which is actually how it was originally implemented and before public release, and the way that worked was just a simple ED 25519 scheme where you just sign in the public keys there. And I was like, this is pretty good. You can focus on the action. And then I was telling Steven about it, and he's like, it would be really cool though if it did generic authentication. And I was like, whatever you say, Steven. So then I ended up ripping out the standard authentication and replacing it with a generic authentication interface. Now, the generic authentication interface is actually just like an action. So like, an action can do anything on this thing. An authentication mechanism can also do just about anything. It just has a few extra things you have to implement to help charge fees. But within that, think about like an action, the primary thing is execution. So like you're executing something, and then as a result, you get a result back from that. And auth, instead, we just call it verifying something. And then you get an error back if it's not verified. And so that verification is just a generic, blob you can fill with anything. And so in the case of the token VM, authentication, in a simple case, this is like how you would implement authentication just for a standard signature scheme, which is I have a signer, I have a signature, and when I verify it, I just make sure that the signature is valid. So pretty standard stuff, right? But you could just as easily in here put anything. So you could put like a ZK proof, you could put some sort of like multi-sig thing, you could put any cryptography you wanted to in this blob, and it would just work with the rest of the HyperSDK. So basically unblocking account abstraction was a primary goal with this. And, some people ask like, this is pretty cool, right? Like, well, why doesn't the rest of Avalanche do stuff like this? Well, HyperSDK, in a lot of ways is a way for us to test some of our newest ideas of like how we would design virtual machines. And then the hope is that, the best things, the no-brainers, make it to the rest of Avalanche as a mechanism that can be reused. And so one of those things we think that will do that is probably the WASM work that we do in the HyperSDK. So to provide some sort of smart contract functionality, we're going to implement a generic WASM kind of execution runner inside of the HyperSDK. And if we end up being very happy with that, I think we could probably extend that to the rest of the network, or bring that to the X-Chain, or something different where we bring contracts into other areas with WASM. But and we've already started to do that with the MerkleDB, for example. So the MerkleDB will be used on the P chain, will be used on the X chain to make state sync faster. So think of the HyperSDK as kind of the laboratory, and then when things get mature enough, we take them out of the laboratory and bring them to other areas of the network. So cool.
Great, thank you very much. So next we have from Crabmunculus. Also related to HyperSDK, can a custom virtual machine be made to replace ERC 4337? Namely these features. Number 1, recovering private keys, wallets without seed phrases, automated payments, and dApps can sponsor gas costs.
Yeah, I think this one's pretty similar to the previous one, so we'll probably, I'm not going to spend too much time on it, which is, yeah, I mean, the authentication module I mentioned can do most of these things. And so in particular, the ERC 4337, which is I think it may be EIP 4337 actually, but the EVM mechanism for account abstraction, basically it involves, you providing some sort of verification and then someone else paying the fees if that verification doesn't actually map to like an EOA. And yeah, you can do that with the HyperSDK authentication module. We haven't seen anyone actually like implement exactly that functionality, but the index VM, if you're curious, does implement like a delegated authentication mechanism that is probably similar to what you may want. Yeah. I think, Gabriel, let's go to the AWM one for the C chain.
Sure. So next, coming in from Chris Troutner, also known as Trout, somebody I've known for many years, an amazing developer. This is related to Avalanche Warp messaging. Is there example code for sending an ERC20 token back and forth from the C chain to an EVM subnet?
Yeah, I can take this one. There's no example code yet, since it's still under implementation, and we're first going to build this out in subnet EVM before moving anything into the C chain. I think that in the case of subnet EVM, because there's a decent number of networks that are using this in production, it's not quite the same as HyperSDK to the extent that we can say it's for use in the lab, but we're still going to use or deploy things first to subnet EVM before migrating them to the C chain. And we're going to implement this in subnet EVM in order to support Avalanche Warp messaging. And then after that, we're going to build protocols on top of this generic messaging layer in order to support bridging tokens, including ERC20s across different subnets, as well as from the C chain to subnets. So the answer is there's not example code yet, but we will have it as soon as those things are out and published, as well as all of the generic messaging to building bridges on top of it. And additionally, I can talk a little bit about what this will look like in the special case of C chain to subnet communication, since we've made some design decisions around this in the past few weeks. So to start out, first of all, for subnet to subnet communication, if you followed Avalanche Warp messaging so far, you're familiar with the fact that for subnet A to send a message to subnet B, the validator set of subnet A will produce a multi-signature using BLS keys that are registered to the P chain, so that subnet B that wants to verify this message also has access to the registered BLS public keys and can actually verify a message that it knows is coming from subnet A. So this is really nice because it basically takes one good way to explain this is for all sorts of different bridging protocols, they all essentially, if you have chain A to chain B, they all essentially rely on some trusted third party, which usually is some multi-sig bridge or something similar. So the real thing that we're doing with Avalanche Warp messaging is taking that essentially a requirement for a trusted third party and turning it into the P chain, which is for one, maximally decentralized, and two, already a core part of the protocol. And so the question here, so this is how Avalanche Warp messaging works in general, in the general case of any validator set or any subnet from point A to point B. And so for the primary network, we could do this in the exact same way, and we could treat it as all of the same way we treat all other subnets, where we assume in order to receive a message from the primary network to some subnet, you have to receive a multi-signature from all validators on the primary network, or obviously a threshold of validators on the primary network in order for that message to actually be valid and for that signature to be valid. The only thing is that the primary network actually has, one, the most validators on it, since right now there is a requirement that every subnet's validator set is actually a subset of the validator set of the P chain. And so that means that this verifying this message from the primary network would be the most expensive possible. And the nice thing about Avalanche is that because every validator of every subnet is actually a validator of the P chain and is actually able to read the P chain state as well as any other blockchain that is on the primary network, we can actually do something that's a lot smarter and a lot more efficient than verifying a multi-signature from every validator. So what we can actually do instead is that every validator of the subnet can actually sign a message essentially to itself, so that they can actually be the ones that attest to what happened on the C chain. And what this means is that instead of verifying a message from the primary network by requiring a signature from every single validator of the primary network, since we're already operating on that subnet in a validator set that it depends on trusting those validators, what we can do instead is we only need to get a signature from the validators that are actually operating on that subnet. And so we will still do the exact same thing where that message will actually include the source chain as the chain on the primary network, or in the case of the C chain's blockchain ID. But instead of requiring a signature that's generated using every single primary network validator, well, instead, if there's 10 validators on a subnet, it'll only require a threshold of those 10 validators, still using the source chain as the C chain, in order for that subnet to authenticate a message having come from the C chain. And this results in, one, a massive improvement to the number. You don't have to verify nearly as large of a signature. And so it ends up being significantly more efficient to verify these messages in C chain to subnet communication. And it also has the nice property that this really doesn't represent any change in security for that subnet, because that subnet is already reliant on its own validator set, obviously. And so this actually gives you the same security. There's really, in this scenario, you're trusting the exact same validator set. So C chain to subnet communication ends up working out extremely nicely, both for performance as well as really making no modifications whatsoever to what your trusted base is for verifying that message.
There's a generic case that's really nice here too, which I don't think we haven't really touched on, is like, we're talking about the C chain right now, kind of as like an external oracle in a sense, or like the validators themselves are serving as oracles of what happens on the C chain. What if they were serving as oracles of something else, right? Like, and if they all provide a signature that ends up being included on chain, like, you could do that. So that's how you could create, for example, like an interesting bridging subnet, for example, that tries to ingest data from another chain, or you could use that to like integrate, different external data without having this dependency problem. And so it's really a generic way that you can bring data into a subnet as long as all the validators agree. And so, because that's really all the blockchain is at some point. It doesn't matter what comes in as long as everyone agrees that that's valid data. And so you can introduce additional like overlay to this with proofs if you wanted to like make sure that it's like, bounded. You can't just like bring in anything if you wanted, but, generically, the idea is that, well, if you have a really great way to verify certain activity generically, involved in that network, like you could really invoke almost anything with that. So pretty cool.
Another really cool thing that you could do here is, because the P chain is pretty generic, one thing you could do if you wanted to just allow some bridge from a completely external network, completely external to Avalanche, to be able to talk to any subnet, all you would really have to do is register some either single BLS public key, that's maybe an aggregate of multiple public keys, or an actual set, and actually use that as a bridge in order to authenticate to what happens on some other network. So one example of this could be if you wanted to have a bridge of a multi-signature bridge from Ethereum to literally any subnet, including the primary network on Avalanche, you could set that up essentially as just registering either a BLS public key or a set of BLS public keys to the Avalanche network, and then verify multi-signatures from that set in order to send a message from Ethereum to any subnet on Avalanche. You could even do something smarter or more interesting, where if you wanted to do something using a lot of the innovations that have been created in ZK-based bridging technologies to actually have a proof of consensus or a light client, you could actually put those proofs on the C chain so that everybody would just have to sort of trust this is a contract on the C chain. We know that this contract is actually verifying consensus that is performed on some other chain. You could actually verify all of those proofs, and then once they're there, you could have a smart contract that essentially handles a proof of consensus, a lightweight snark that verifies this proof of consensus, and then immediately sends a message via warp that can then be delivered to any other subnet that attests to what happened on some external chain. So you could think of this as a way to essentially register proofs of consensus coming from any external network, which I think would be really cool.
Cool. Yeah, I think we're running up on time here, so I'll turn it back over to Gabriel to close us out.
Yeah, so thanks everybody for joining us. We're going to pass the mic around one more time just to get final thoughts. Steven, any final thoughts?
Not really. I'm just excited to see Cortina finally coming together. It is literally been years of work, of iterations on wrapping this stuff up. So yeah, really excited to see it all coming together. And yeah, I would yeah, I'm really excited to give a technical deep dive at some point, but I don't know when exactly that'll be. But that would be a lot of fun to dive into the details, because we're doing some pretty interesting stuff during Cortina. So yeah, it's pretty cool. I don't know.
Excellent. Thank you very much. Aaron, any last minute thoughts?
Thanks all for coming. Appreciate the questions as always, and really excited for open development and having more of these so people can come in and use this as an open window to ask whatever is on their mind, and we can help the Avalanche community more.
Awesome. Thank you. Patrick, any thoughts?
Yeah, I mean, I think we're always trying to ship cool stuff, and so let's keep doing that. That's really it.
Sounds good in theory.
Yeah. So again, thank you to these gentlemen for joining us. One last minute thing we want to mention is the Avalanche Summit. The second Avalanche Summit is coming up on Wednesday, May 3rd through Friday, May 5th in Barcelona. Last year, there were around 4,000 people there. This year, we're expecting 300 speakers from all over the world, 125 different panels, probably similar in number of people, 4,000 people in an absolutely beautiful spot in Barcelona. Probably the best crypto conference I've ever been to. Truly, you know, next level. So this is coming up. Check out avalanchesummit.com. You can learn about tickets. And if you are going to make it to one crypto conference this year, this is the one. So please, I hope to see everybody there. Again, Wednesday, May 3rd through Friday, May 5th, avalanchesummit.com. So again, thank you to these gentlemen. As I mentioned, we're going to be doing this every couple weeks. So look out for the next one around April 5th. We'll be sharing an input form on social media, or as I mentioned, you can leave them in the YouTube comments, and we gather any questions for these amazing gentlemen on the next session. So thank you to everybody for joining, and we will see you next time. Cheers.
Thanks, everybody.